Okay, good afternoon, everyone. Today we are going to talk about the resiliency, security, chaos testing tools for the container cloud deployments. Before we begin this session, let me introduce myself. I'm Pradeep Kumar. I work for Ericsson India Private Limited, and I work as a solution architect, and I also work on the AT&T's Airship Network Cloud project. So here is a brief agenda about what we'll be talking about. So we'll be talking quickly about the importance of resiliency chaos testing. We'll also be looking at some of the security auditing and conformance for Kubernetes. And we'll also try to evaluate a couple of tools. So firstly, we need to understand why resiliency and chaos testing are important. Right? A lot of us, we do the functional testing. We also do some stress testing and load testing and so on. But what we do not probably consider is, as we are moving towards the containerized deployments, we do not look at really the resiliency part, because the way the Kubernetes are brought up and so seamlessly, we do not understand that they also can cause a lot of failures. They also become single point of failures as well. So it is very important that we do this kind of testing to ensure that in the production, whenever the pod fails due to intermittent issues, it comes back on its own and doesn't really cause loss of service. So the three main things, that the reason why we do resiliency testing is to deal with the unexpected failures in a distributed system like Kubernetes, which orchestrates the containers. And as we move to the microservices architecture, it needs to be resilient. That is the most important thing that we expect out of a containerized deployment, so that it restarts either on the same node, or whenever there are pod failures because of lack of resources or any other issues, it can seamlessly come on other nodes on the cluster. So this also ensures that the upgrades and downgrades are more reliable, and we can confidently do the upgrades and downgrades without needing to worry about what would happen in case of failure. So we would be doing the testing would ensure that confidence before production. And like I told you, I mean, the failures are pretty common in container environments, and that's how we need to make it robust, and resiliency is one of the ways to make them robust. So apart from this, we also have the security audits and conformance tests that we need to continuously be performing on the K8s cluster, the Kubernetes cluster. The security audits and conformance tests need to ensure that the record of calls that are made to the Kubernetes API server are audited, and they're maintained in chronological order or in the sequence of timestamps. And they also need to be investigating on suspicious activities, APIs requests, and also it needs to periodically collect statistics and monitoring alerts. And it also needs to ensure that the network layer is also secure enough. So that's why we need to ensure that the traffic between the pods are restrictive in nature by hardening it through network policies. And we also need to we always need to go with the least privilege access mode. You cannot give over privileges when it comes to network security on containers. So apart from this, we need to protect metadata. They are another set of important information that we need to protect. So security audits need to be robust enough to catch such vulnerabilities. And we also have the upgrade scenarios that also needs to be considered while doing the security auditing. And obviously the pod permissions, and they need to be protected using pod security policies as well. So some of the tools that we have evaluated and that I'll be talking about as part of this session. The first one is actually a Kubemonkey or the Chaos Cube. So both are similar products. Similar set of tools which provides chaos testing. Now the chaos testing is a mechanism where you randomly kill pods on an environment just to ensure its behavior is consistent and do not have any abrupt errors or maybe failures and so on. So we randomly bring down pods, and we can bring down the pods based on labels, annotations, namespaces, and so on. You can add them as filters while doing the testing. And these are declarative in nature, so we can declare them in a YAML file, and we should be able to test them based on a smaller set of pods. And also we can set filters to ensure that the chaos tests run periodically, sometime in the week, sometime a period of time when probably the loads are not pretty high and the vulnerabilities are not going to affect the end user. So we can also set them or schedule them. So like I told you, I mean, these are two different tools. The primary difference between these two tools are the KubeMonkey allows us to specify the mean time between failures, which Chaos Cube doesn't allow. Probably that is one of the main things that is very important while considering the chaos testing. And also the other ones are the filtering capabilities that KubeMonkey provides, which are not available on Chaos Cube. So we can choose the correct or the right tool sets for chaos testing based on our needs. So the other tool that we are talking about is the Cubebench. Cubebench basically provides you a benchmarking capability. We already know that Kubernetes has a benchmarking capability built into it. So that way, all the pods, whenever they're coming up, it ensures that these benchmarking capabilities are met. But we need to also periodically watch out, and we audit and also run tests to ensure that there are no flaws in the benchmarkings. So Cubebench provides you that capability, and these benchmarking tests are provided by the CIS. So whenever you run the tests against running a Kubernetes cluster, you would be able to find flaws. As you can see, some of the examples here, I've deliberately showed you some examples where there are failures. For example, if you look at the first failure, it says the privilege is set to false. The allow privilege in the configuration is set to false, which is not the correct thing to do when you're setting up a Kubernetes cluster. And the other common mistakes that we probably do is setting up the anonymous path, and we also have the kubelet HTTPS. So if you don't enable that, that's again vulnerable because it's not using the secure HTTP. So likewise, you have a set of benchmarking tests which are defined by CIS, and we need to run all these tests and ensure that the Kubernetes cluster is certified. The next tool that we are going to talk about is the Audit. These are pretty similar to how benchmarking would work, but these would mostly look at some of the configuration files on Kubernetes and the permissions that we provide on those files. It could be the files, the application files running within the container. It could also be some of the configuration files of Kubernetes itself. So we cannot give over permissions to any of these files, so we need to ensure them. So some of the audit tests that we have here, and also the most important thing that we do, that we need to take care, are providing host path access. You should not be giving complete access to the host when you are running a container. So that also needs to be audited. So these tests, some of them, I can just read it out here. The root file system access, you should always run it as a non-root. You should always allow privilege escalation. That test also needs to be run. And some of the network policy, app armor, seccomp, and these are some of the auditing tests that we need to periodically run and ensure your Kubernetes does not leak any of the files. So the last one of this list is a Ceph benchmarking tool. The Ceph benchmarking tool provides you a benchmarking capability for your Ceph cluster on your containerized environment. So what it does is it randomly brings down, or it can actually create and destroy the OSDs on your Ceph cluster. So by doing that, you would be ascertaining that the Ceph is more robust, and Ceph can actually spin up that many OSDs whenever needed or whenever there is a requirement. So apart from that, the Ceph has the capability to record the system metrics with the help of collectl, and it can also optionally collect more information using a number of other tools like perf, BLK trace, and Valgrind. So apart from this basic benchmarking that we can do using Ceph, it can also do some of the advanced tests, including OSD outages. I mean, these are remediative actions based on the tests. So it can actually do a OSD outage if the benchmarking is not met. And it can also erase some of the coded pools, and it can also cache the tire configurations in case if they are not passing the benchmark. So the tools basically used for this remediation are again Rados Bench, lib RBDFIO, KVM RBDFIO, and RBDFIO. yeah, that's all I have for today. If you have any questions. Okay, thank you so much.